Morning, my YouTube viewers. It is Crystal here. I'm here because I have done another Kaggle competition. Kaggle has their competitions every month. They have a playground competition every month. And so every month I do a playground competition. I'm a little bit late getting this playground competition done because I was busy doing some other things because I stay busy in my studies. But this playground competition is 5.10 and it's going to be catboost regressor. And so the competition question is to test on the probability of a road accident. And I got a RMSE of 0.05559. And so the highest score was 0.04 something. And so I decided that since I'd scored so close to the highest score, I wasn't going to do anything to try to make it better. So I decided that I was just going to stick with the catboost. And so that's what we're using in this particular video is catboost. And catboost is there because it works on categorical values. And because it works on categorical values, it's really popular. So we've already talked about our problem statement, which is to test the probability of a road accident. And now what we're going to do in this particular video is we're going to import our libraries. So we're going to import NumPy as NP, which is a numeric library that creates NumPy arrays and performs numeric computations. It also creates distributions. We're going to import pandas as PD, which is a data processing library which creates data frames and series. We're going to import OS, which is a library that goes into the operating system. We're going to import sklearn, which is a library that provides machine learning functionality. We're going to import catboost, which is the model that we're going to use on this particular problem. We're going to import matplotlib.pyplot as PLT and also Seaborn as SNS, which are visualization libraries. So we're going to retrieve the files. We're going to use OS to retrieve the files. And the files that we have are going to be sample submission.csv, train.csv, and test.csv. And then we're going to read the files. And so we're going to use pandas to read the files. And train equals pd.read.csv. And then the web link or the link for train, and we're going to do the same thing for test and the same thing for submission. So we're going to have 3 data frames being train, test, and submission. We're going to set it up. We're going to use pandas to set it up so we can see all of the columns, because if you have a data set that has a lot of columns of data, the Jupyter Notebook won't show all of the columns unless you set it up to where it will show the columns. So we've got train, and then train has 14 columns of data, with the last column being the percentage of an accident risk. And you can see you've got strings, or you've got object columns and Boolean columns and numeric columns and float columns. And then so here we do an info on train. So you can see you've got integers, objects, floats, and Booleans. So we've got, we check for the null values. You'll see that you've got no null values in the train data frame. And then so what we're going to do is we're going to take the Boolean and we're going to convert them to integers. So a true is 1 and a false is 0. So we're going to replace true with 1 and we're going to replace false with 0. And then we check our info again, and you can see that Boolean has been taken out of the D type. So now it's just integers. So we've got the test. The test has got the same format as the train one, with the exception of the fact that it does not have a risk of accident column, because that's what we're going to be predicting on. We check info. Again, you can see that the format is the same as what was with the train file. And then so now we're going to do exactly the same thing with the test file that we did on the train file, is we're going to convert the Boolean to an integer by replacing true with 1 and false with 0. So we check our info again, and you can see all the Boolean d-types have been removed from the data frame. We check for any null values. You don't have any null values. Now we check for submission. So you've got your ID and your accident request, and that's the format that Kaggle is going to want to see when you submit your work. So we're going to drop the ID column. The reason why we drop the ID column is because Pandas automatically indexes every row of data, so you don't need an ID when you're using Pandas. We're going to analyze the data frame, so we're going to create a histogram of the target, which is accident risk. So this is your target, and you can see that it is right skewed. So now what we're going to do is we're going to identify the categorical columns. The 4 categorical columns are road type, lighting, weather, and time of day. And then what we're going to do is we're going to create a plot of these 4 different categorical columns. So you can see we've got the plot here of road type, lighting, weather, and time of day. So now what we're going to do is we're going to locate the columns that are of type integer. So the columns that are of type integer are num lanes, speed limit, road signs present, public road, holiday, school season, num reported accidents. So now what we're going to do is we're going to create a plot of all of the columns of data or features that are of type integer. So here it is. You've got your num lanes, you've got your speed limit, you've got your road signs present, you've got your public roads, you've got your holidays, you've got your school season, and you've got your num reported accidents. So now what we're going to do is we're going to find the features that are of D-type float, and then the features that are of D-type float are curvature and accident risk. And so we're going to create a hist plot of those 2 features. So you see you've got curvature and then you've got accident risk. So that shows you the curvature and also the accident risk. So what we've done is we've analyzed the train data frame. So now we're going to one-hot encode the categorical columns, and you're going to need to do that with catboost, because the nice thing about catboost is you do not have to convert the categorical columns to numerical columns by encoding them, but you do have to one-hot encode them. So we're going to one-hot encode our categorical columns. We're going to use the get dummies command. And then what we're going to do is we're going to do that with the test set as well. And now we're going to define our dependent and independent variables. Y is train.pop accident risk. So it's going to pop accident risk out. And then X is train and X test is test. So now what we're going to do is we're going to use sklearn's train test split to split the data set into training and validation sets. So you can see that. And now we're going to develop the model. Model equals catboost regressor, and loss function equals RMSE, and then model.fit x train y train for both equals 100. So it's going to train it 100 times. So there's a possibility if you made it verbose 200, then, well, there's a possibility that if you trained it more, it would have a better RMSE. So now what we're going to do is we're going to get our RMSE for the validation set. So ypred equals model.predict xval, and then we're going to print the validation RMSE is the square root of your MSE, yval, ypred. So your RMSE for your validation set, or ypred, is 0.056. So we're going to plot the results using matplotlib. So you can see that this is the results that we plotted. So it looks pretty good. Now we're going to predict on the test set. Pred equals model.predict x test. And then we're going to create a histogram of the predictions. So these are the predictions. And then we're going to prepare our submissions. We're going to put pred in the column of accident risk in the submission set. Then we're going to convert the submission data frame into a CSV file. And then we're going to look at the CSV file, convert it back to a data frame, and you can see this is our CSV file. So these are our predictions. And so what we did was we save it, and then after we save it, I made it public, so anybody that wants to see it can see it. And then we submit our predictions to Kaggle, and I got a 0.055, which isn't bad. I don't think it's bad. And I decided that I wasn't going to try to improve it by using another model, and I would just stick with the model I've got. So that's it for this particular competition question. I've covered the code, and so what I'll do is I'll leave a link to the website, so you can look at the website if you like. So thank you so much for watching my video. If you like my video, please like and subscribe, and I'll be making another video for you on Kaggle's playground competitions next month.